Blinded by the light, wrapped up like a douche, another runner in the night. Blinded by the light, wrapped up like a douche, another runner in the night. Blinded by the light.
So if you ask it to take you to the chair, we'll be happy to guide you.
Find a chair.
Find a chair. Chair. Oh, sorry.
So the device is your robot guide dog, you could say, and the idea is that it will pull you or give you information of which way you're supposed to go, and it's quite intelligent, so it plans routes for you, but it also avoids obstacles on your way. And the things that we are focused on is the obstacle avoidance part, and also some extra features such as reading signs aloud, and and also recognizing faces. So we had this idea that you could actually have a system where you trained your robot dog to know your friends, or at least maybe also those you don't want to meet. And then you could ask the system, is there anybody present in this room that I know, or how many people are in this room? And then it will count, and it will tell you that your friend Eric is here, and you will see that on the video. And what?
Giorgio, take me to the nearest exit, please.
Okay, system starts running. System avoids obstacles. System avoids another obstacle. Stairs. And what? Yeah, we also had this idea that it would be a nice thing if we could do object recognition, so we could ask the system to take us to the nearest empty chair, which is also a thing we have tried to make a small example of. Yeah. So, well, it's basically, we think of it as that either you can collect information about the room, and you should probably collect this kind of dynamic information when you walk around in the room, so you have an idea of where are the chairs, if that's what you want, or where's a table or the nearest door, and so forth. Or if you don't know anything, you have to do a search, so you have to walk around the room to find whatever you're looking for.
In this room, there are 7 people. Eric is here.
So the next thing is an example of reading signs. And it detected a sign and reads the sign.
Information, reception. Information, reception, restaurant, naturskole, galleri, varemodtagelse, restaurant.
Okay, so the idea is that you could either you could ask actively the system read signs, and then you would have to search, but you could also have the system put into a mode where it will read signs for you if you pass one.
Would you need a sort of a little, maybe not a Harry Potter stick, but a Harry Potter wand that you can just
extra
yes, get out of it, like some sort of thing maybe attached to the handle, like concealed in the handle, and you can take it out, and it's attached to the handle by an elastic band, so it doesn't get thrown away. So you can just hold it in the air and find an empty seat or whatever.
But that wasn't really the plan. The plan was that you didn't. We don't really want that the users should have to do this.
Yes. Okay.
Because it would be nice that we could solve these kind of things for him on the fly.
So you count on doing it from
the
a meter
cameras,
above the ground.
or maybe higher, depending
Yes.
on where we put the cameras.
Yes.
So
But we would be able to avoid obstacles from rather low cameras.
Yeah.
If we want to plan the way around tables, we need a high camera that can overlook the tables, the configuration of those.
Yes.
Otherwise, we'll just try walking around them and looking at them as a local obstacle.
We thought of having 4 levels of abstraction. So a global level that contains information about your current position and would be able to access information from maps, GPS systems, wireless LANs, basically whatever that it would take to estimate where you are and how you would get from point A to point B and calculate a route from this. So that's the global level of the system. Second level is more or less the level we just heard about, namely navigating in your immediate vicinity, finding obstacles, getting around them, and sort of the key word for level 2 is to get around things and not sort of showing that the things are there. There's no idea in bumping into things if you can just go around them. And level 1 is very close to the person or the car, so that could actually be a hit or a situation where the system asks for user input. What are we going to do now? Let's say we are at the bottom of a staircase and I want to do something addressing the first step, whatever. It could also be switching back to sort of the manual cane to get out of this situation, because we can't avoid everything. So level 3 would be based, or the global level would be based on maps, global information. Second level on cameras, range finders, stuff like that. And the lowest level basically on collision detectors to find out, hey, we hit something. And I think that's more or less it for the sort of very overview of the system. And then
what we have tried to address is what kinds of information we get and how, what kinds of information we want to get out to the user. That's basically the drag of this digital guide dog, which way it goes, tries to lead you, and also some spoken warnings that there's something ahead or an obstacle, or that you'll reach your destination or you're halfway, something like that. And we have tried to think about the control logic that would take all these inputs and produce the desired outputs, actually the guidance for the system. And we'll make a small scenario, walk from the station, an outpost station in Copenhagen, and walk from there to the IT University in Gällivare. And so I think it would be useful to one of the stage art authors to explain
Okay.
that.
The visual. So you have to imagine that you have a triangle that's turned upside down with the, what is it called, the angle pointing downwards. And there you have a state. That's the standby state. It's a dynamic state where the system is doing something, except that in this particular state it's actually doing nothing. Then on your left you have a state that's deliberative control, which means you're following a plan. And then on the right of that you have a state that's reactive control. So what we have chosen for the control architecture is a classical architecture that's an interleaving of deliberative and reactive control. There are a lot of researchers that believe in complete deliberative control. There's another group believing in pure reactive control. But for this particular task, it's a good idea that the system can go very reactive if you have a danger like a bicycle or something like that. Maybe worse. What is the current level of information? How much do we believe our information? So now let's try to expand the deliberative control state, and we're using state charts here to explain it. So when the deliberative control state is expanded, you're looking inside of this state. We're kind of saying what's going on inside. So now you have to imagine that you have a range, or you have a hierarchy of substates within this state. Then something can happen. For instance, we could actually hit an object. Whoops, like now I'm expanding the reactive control, and in this state we also have 4 control states, and one of these control states is static object avoidance. So now we're doing vision controlled avoidance of this object, and when the situation is under control, it's out of our way, we replan and go back to deliberative control. In a place like, for instance, Købmagergade, you'll have to avoid obstacles all the time. Lots of people, lots of things, and shopping things in the street. Lots of people not caring where they go. I think what you have to do is to really get the reactive mode or the reactive part and the planning part, the deliberative part, to coordinate. Otherwise you would have to do a lot of planning, replanning, planning, replanning, planning, replanning all the time. I forgot yesterday, but what I should have done yesterday was to make you feel the difference of being guided from behind rather than being pulled from the front, from up front. That you can grab something and it moves in the right direction, and there's a physical thing going in front of you that will take the first collision maybe.
I would like to have Bue to experience by himself how this will work. So Bue, will you please come up and take a hand here?
Yeah.
This is...
Do you have like those are one of those sticks we used yesterday? That could be level 1 investigation.
For you?
Yes.
You mean?
Yeah.
Yes.
Thank you.
Here we go.
So perhaps you should explain firstly the user input motion controls.
Yes, indeed. If you want to increase the speed, you should just push it a little bit forward. If you want me to go slower, you should hold back. And if you want it to stop, you should just release the grip.
Yes. Yes. What command have I given you now? Have I given you? Are we going anywhere in particular, or are we just going?
I'm just demonstrating
Okay, yes,
basic
okay.
navigation
Yes.
level 1 kind of interaction.
Great.
Okay?
Forward.
Then you would make a request while it will stop, and you'll do that by a simple button press on top of the handle.
Yes.
Obstacle in front, please reverse. if the system becomes unconfident, you will feel a small vibration in the handle. This is not a small vibration, but it's it will of course be gradiated to indicate how uncertain it is.
You don't want to push the dog because there might be an obstacle just in front of you. You simply let the thing guide you faster. And in terms of commands, like find the chair, find staircases, you might very well be inspired from the commands that you use with a living guide dog. They are things like, these are mainly level 2 commands, of course, because a guide dog wouldn't know what to do with level 3. You don't have command, find the chemist, find the baker. They do not exist, even though some people tend to use them. Well, but they are commands like find left stairs, find right stairs, find, and you can put left and right on everything. So stairs, curb, or step, or whatever. Chair, find left way, find right way. These are all level 2 commands. Find right way means, find right path means I want to go to the right at the first possible junction.
So if we could model these on dog commands, that would be probably the best. It could be, though, that for level 3 information, it would be nice to have the ability to also make the inputs a little bit more informal, slightly more verbose, so that the way we would handle that is that in the background, implicitly in level 3, are going to be knowledge bases involving maps, possibly 3D information for particular buildings, whatever other information may be appropriate. And along with that would be what we call a dialogue knowledge base, which are sets of context-dependent clusters of typical dialogues. And the way that this works best and is most robust is if the equivalent class of inputs is reduced down to one representative of the class, or in normal form. And that way, I think it will allow the user to be a little bit less conscious in some situations of precise syntax, or
Blinded by the light, wrapped up like a douche, another runner in the night. Blinded by the light, wrapped up like a douche, another runner in the night. Blinded by the light, wrapped up like a douche. Madman drums, runners, Indians in the summer with the teenage diplomat. In the dumps with the mumps as the adolescent bumps his way into his hair. With a boulder on my shoulder, feeling kinda older, I tripped the merry-go-round. With his very unpleasing sneezing and wheezing, the calliope crashed to the ground. She was blinded by the light, wrapped up like a douche, another runner in the night. Blinded by the light, wrapped up like a douche, another runner in the night. Blinded by the light, wrapped up like a douche, another runner in the night. Blinded by the light, wrapped up like a douche, another runner. Some silicone sister with the manager, mister, told me I got what it takes. She said, I'll turn you unsun into something strong. Play the song with the funky break. And go-kart Mozart was checking out the weather chart to see if it was safe outside.